All right, everyone, let's take up the final topic for today's lecture, um, which stands somewhat in contrast to the assumptions that we've been operating with for the past week, um, under which we have always tried to account for allomorphy, for alternations in the forms of morphemes by using phonological rules. But it turns out there are some rather difficult cases where maybe this is not the right approach. Usually it is a productive strategy, a good strategy to assume unitary underlying representations. That is to assume that a morpheme has a single phonological underlying representation, and to work out to develop a system of phonological rules to derive the other allomorphs. But there are some instances of what we should call allomorphy that can't really be derived through phonological rules. And there are two main types of problems that you may encounter. One are instances in which the different allomorphs are phonetically so different from one another that it's implausible to use a phonological process to derive one allomorph from the other. And secondly, sometimes any conceivable combination of an underlying representation plus some phonological rules is falsified by other data in the language. And sometimes both problems are present at the same time. As the first example, let's consider the ergative suffix in an indigenous language of Australia, yiding. And this suffix is realized as ngu when a stem ends in a vowel. So for instance, the word waguntiangu, but it's realized as du when a stem ends in a consonant. So warabaldu. So these are the two allomorphs, ngu and du. They look sort of similar. They both end in a vowel, but there's a consonant sequence that is quite different. One has a nasal and a velar stop. The other has a coronal stop. Deriving one from the other is a little bit problematic. Maybe you can do it, but it looks rather difficult. If I think maybe a more productive approach that, or a more reasonable approach that morphologists would agree on, would be to add some phonological information to a morphological rule. So for forming the ergative in yiding, we might say that there are two rules, not just a single rule generating a single underlying phonological representation, but a rule which says that a suffix u, a suffix ngu is added to a preceding sequence of segments where the last of those segments is plus syllabic, and otherwise add a suffix du if the last of a sequence of segments is minus syllabic. So what we would say here is that although the normal circumstance, the circumstance that we usually assume, is that a morphosyntactic feature bundle is associated with just one lexical entry to generate a single phonological underlying form. In this case, we're saying that these two rules, that this morphosyntactic feature bundle can be associated with more than one rule, and those rules look for phonological information in the input. So in this case, where the choice of the two different allomorphs, ngu and du, depends on some local phonological conditions, we're using the X to stand for all segmental material that isn't explicitly mentioned. So in these two examples, the X would stand for wagud, and plus syllabic captures the A. And in the latter case, in D, the X means the sequence warabal, and minus syllabic means the L there. And this system, such a system with a couple of morphological rules corresponding to a single morphosyntactic feature bundle, isn't so crazy if we think that the lexicon already needs to store phonological information. But the bigger theoretical leap here, the thing which we have mostly been avoiding as far as possible, is that the morphology itself, that these inflectional rules can look at that phonological information, they can see it, and that they don't just apply blindly, adding suffixes or prefixes or whatever. So we might want to keep in mind that probably insofar as infixation, something like infixation, occurs in the morphology, that would require for morphological rules to reference phonological information, to find things like the leftmost consonant or the first vowel in a phonological sequence. So maybe it's not so problematic to assume that morphological rules can see phonological information that comes from the lexicon. Our second case of an instance where we find allomorphy that is difficult to explain phonologically comes from Korean in the form of the nominative suffix. So in the examples on the left, we see a suffix e, and in the examples on the right, we see a suffix ga. So on the one hand, words like muni, door, versus tanoga, word. And the generalization about the environments of these allomorphs, these two allomorphs, e and ga, is fairly straightforward. E occurs after consonants, and ga occurs after vowels. In such a case, in terms of trying to account for this allomorphy phonologically, we could assume is that the suffix is underlyingly e, or the suffix could be underlyingly ga. And then, depending on what we assume the underlying representation is, we can write a corresponding rule. So if the suffix is underlyingly e, then we need a rule whereby underlying e is transformed into ga following a vowel. If we make the opposite assumption, specifically that we have a suffix ga, then we would want a somewhat strange-looking rule that targets a sequence of sounds, a sequence ga, and changes them into a vowel e when preceded by a consonant. So one can easily imagine a combination of underlying representation and rule to derive the allomorphy. However, of course, we see the first of the two problems that we mentioned above, namely that deriving e from ga or ga from e is phonetically not so straightforward. And the worst problem, the more difficult problem, is that either of these two phonological rules is falsified by other data. So in the left-hand column here, we see instances of an e following a vowel. So if we adopted the first process, and we can see that the word for cucumber surfaces as oi, let's assume that this word is underlyingly oi. This rule would predict that they would become oga, that we would obtain the sequence oga out of the application of this rule. And just the reverse, we find instances of the sequence ga following a consonant. So the word for tapsang, yuhenga, there, let's assume that the underlying form is yuhenga. In this case, this rule ought to apply and transform an underlying ga after a consonant into e. Let's mark these as ungrammatical, as not actually occurring words. It should come out as something like yuhengi, which doesn't actually occur in the language. So other data in the language makes it impossible for either of these two rules to actually exist in the language. This means that, again, we can we would need to try to explain the allomorphy in Korean in the same way that we just did above for yidin, to assume that there are two different morphological rules realizing nominative case in Korean, one which adds a suffix e if the stem ends in a consonant, and one which adds a suffix ga if the stem ends in a vowel. Overall, and these two different types of allomorphy, thus far, I would say this means we can perhaps divide allomorphy into two different types. In general, we have approached allomorphy as phonologically driven. And by phonologically driven, I mean that the allomorphs are created by the application of phonological processes. In the Yiding and Korean cases that we've just seen, I think we can describe, I would instead describe the allomorphy there as phonologically conditioned. That is, the morphology needs to look at some phonological information in order to know which different allomorph to apply. And in order to distinguish between phonologically driven and phonologically conditioned allomorphy, I would do two things in general. So one, you can look for gaps in phonological patterning, such as would be eliminated by a rule. And those prove that a phonological rule is sufficient. And also look for multiple morphemes that alternate in the same way. And those prove the general applicability of the rule, namely that the rule is probably necessary. So for instance, something like obstruent devoicing in English applies to multiple different morphemes. So obstruent devoicing in English applies to plural z and possessive z and third person singular present z, and also to past tense duh. This rule, obstruent devoicing, generates allomorphs s in these cases, and generates an allomorph ta with a voiceless alveolar stop for the past tense suffix. So that shows that those allomorphs of these different morphemes are probably phonologically driven. Okay, so now that we've seen that although we as phonologists prefer to, as much as possible, try to explain allomorphy using phonological processes, there probably are some instances in languages of the world where phonology alone is not going to be sufficient for accounting for the allomorphy. Okay, thanks everyone for listening today, and I'll see you again next week when we talk about bounding domains. Take care.